Welcome to springlib.
Okay, we have the following product. And what we'd like to know is what molecule, upon ongoing ozonolysis with O3 and here it's zinc and H2O, would have given this diketone as our product. Now, what I'll point out, recall, is that if we have some alkene and we undergo ozonolysis, really what we're doing is chopping that alkene in half and putting oxygens where there used to be double bonds between those two carbons. That is, one of them will get two products. It'll turn into this, right? And the other one will turn into this. So if we want to go from ketones back to alkene, what we're really talking about doing is gluing these two halves together and getting rid of the oxygen, right? So the reverse, right? The reverse process is basically just gluing those two oxygens together, like so. Okay, and that's exactly what we have to do here, is glue this oxygen or this carbon in a double bond back to this one, right? And so I think the easiest way to do that is simply to count the number of carbons starting from one of the carbonyl carbons. So 1, 2, 3, 4, 5, 6. And then we know basically that, okay, if we glued these two together, we'd be forming a 6-membered ring. It would start at carbon 1, 2, 3, 4, 5, and get to 6. And then 6 and 1 would be, remember, connected via a double bond. Okay, so I'm going to draw a 6-membered ring. I'm going to number them 1, 2, 3, 4, 5, 6. And then I'm going to connect 1 and 6 with the double bond to represent the gluing of these two together. Right? Removal of the oxygens, gluing together. And then I'm going to say, are there any additional atoms that I need as part of this, as part of my starting material that I'm trying to guess? And I notice, well, on carbon 1, we did have a methyl group sticking off. So I stick a methyl group off carbon 1. And then I look at our possible answers, and I see that 2 is the same thing but flipped over. Basically, it looks like this, which is the exact same molecule. So 2 is the answer.